Okay, and now we're back in the Egeria Dojo for the session creating a second server and connecting via a cohort. So far we've just been working with a single server in the Docker environment. But one of the key things with Egeria is actually allowing multiple metadata servers to exchange information with each other. So we have to get those two working. And rather than go through the steps of setting that up yourself in multiple Docker containers or setting it up locally, both of which would be possible, what we're actually doing here is we're going to use a tool that's called Docker Compose, which actually will let us orchestrate to some extent multiple containers together, which have the different capabilities that we need within the cohort. So Docker Compose is a standard part of Docker for Windows and Docker for Mac. If you're on Linux, you will need to download Compose directly from Docker. But it is available and you can give that a go. If you've got any questions or issues with that, just post in the chat or ask now. Has anyone so far not got hold of Docker Compose? Might be worth actually at this point, I don't know if it's in the charts, Mandy, just running docker-compose at the command line, see if you've got access to that tool, because we're going to be using it in this exercise. There's various different ways that we can run multiple containers together. We'll get on and talk about another way a little bit later on, which is to use Kubernetes. But Compose is a kind of simpler environment that's kind of good for getting things up and running quickly without too much complexity. Okay, so what we also need to do at this point is get hold of the source code of Egeria. The reason for that is that the Compose definition file is actually checked directly into the source tree. Now, it would be something that's quite easy to put externally. We haven't done that yet. So the first link on this page I'll just go into is to download the Egeria source. And I think Susan asked right at the very beginning of the session when we started this morning, did everyone have access to Git? Because we're going to do a Git clone of the Egeria repository. That's basically making an entire copy of it and pulling it down to your workstation environment so that we can use some of the files that are in there. Okay, hopefully you can still see my web browser on one side of the window.
Yes.
Perfect. Okay, I'm going to open up a command window. I'm running on Mac OS. If you're on Linux or Windows, the command should be pretty similar. I'll do the font bigger there too. Right.
That's really good.
Right, can everyone see that okay? So we used Docker in the last exercise. I think the first thing I'm just going to do actually, now that I open this window, is just shut down the container I had from that last session. I suggest everyone does this at this point. Okay, just to make sure we're not going to interfere with anything. Okay, and if you notice, if I type Docker Compose, I've obviously got the command installed. And also I have Git installed. So if you type both of those, you should get the appropriate help text, so you should have it installed. Post in the chat if you've got any problems. I'm going to make a new clone of that, so I'm just going to go into a new directory, because funnily enough I have the Egeria source code around and I don't want to do anything with that. So I'm just going to do a git clone. This is in the presentation you see on the right hand side. And this is just pulling down all the source code. And what we now have in this subdirectory Egeria is the Egeria source code tree. Okay, perfect. Okay. What we're going to do here is we're not going to go ahead and build the code at this point. That's part of another tutorial. We're actually going to go back to, as it says here, if you're working on the dojo, return to day 1 to carry on with the exercise. And that is to run this command here. But first, we have to be in this directory, which is where all of our compose scripts are. So we're going to go, I'm actually already in Egeria. So I'm going to go to Open Metadata Resources, Open Metadata Deployment, Compose, Tutorials. It's not very much in there. And what I'm now going to do is start up this environment. So I'm actually going to pull the images first because I may have got outdated ones from what I was doing a short while ago. So I've been building my own images, so I just want to make sure they're the correct ones. Pull is very similar to up, but if you already have the images rather than starting the ones you've got, it makes sure the very latest ones are pulled down from the network. It's actually something we have in our main documentation about using the compose images. They are probably just under a gig in total, I would guess. If you already have them, you don't need to do this. We've been working on some code changes, so mine would have been the wrong ones. Okay. So what I'm now going to do is do an up. And what this does is it says it will start each of the containers that we have specified in the YAML file. And unfortunately, some of them do have login enabled at rather too verbose a level, specifically Kafka, which Kafka is what we use for the event bus. It's a pub sub mechanism, a very popular one. Also uses a component called Zookeeper. So they're two parts of what we have. And then as well as that, we have UI, which is the Egeria user interface, which David will talk about a little bit later. And then we have 4 Egeria platforms. So we have Factory 1, Core 1. Actually, it's basically called Factory, Core, Data Lake, and Dev. The one has been added automatically by Compose. So we've got 4 separate platforms which we're going to use. Now, the next part of this exercise is really just about creating the second one. This environment does a bit more. It has these things we call notebooks. We're also going to talk about those later, which run an even more complex environment. But at this step, we're just going to run 2. So let's see what we've got in here. Okay, so this is all about what a cohort is. So in Egeria, a cohort is basically a group of different servers that will share metadata in some way and provide common access across those different members of the cohort to that metadata. So those servers can exchange information via a pub sub mechanism, which is in fact using Kafka that we see here, as well as having synchronous requests and allowing connectivity between those different servers. So we're going to set up one of those environments as part of this exercise. Just working out where we go next in the exercise.
So basically create 2, basically we need to configure 2 servers.
It's actually the first time I've seen the content, sorry.
That's fine. So basically we need to use Postman to configure a couple of servers. Well, we can do one of 2 things. We could go straight into the notebooks and follow the configuration there, which will issue the request. It's probably good enough actually, because people have played with the basic Postman requests. So why don't we go directly into Jupyter and follow and go through the process of configuring the servers and bringing the server environment up.
Okay, yeah, no, I think that probably makes sense because there's been quite a lot of time we've spent going through the Postman side of things.
Yeah,
so
exactly, it's tedious. It's we've got so much automated now.
That's right. That's right. So what I'm going to just do is open a separate window. I'll just make that bigger. Oh gosh, it's gone off the screen.
That's what I had problem with mine.
Yeah. When you create it, I thought it was just going to make the text bigger and keep the window the same size, but never mind. What I was going to do is just do a Docker PS, which is going to show us what we've actually got running a little bit more clearly. and that's probably as good as we're going to get. So we have quite a few different containers. So Tutorials UI, the UI. This is the one that we're just talking about, Jupyter. So Jupyter is a popular tool used by data scientists to run analysis on data, often in Python. It supports other languages as well. But it's basically a very generic framework. It lets you combine code and documentation together. And when we started creating some of these tutorials, we thought it was quite a good vehicle to combine that explanation with executable code fragments that we can walk people through. So that's what we're going to look at in a minute. So we're going to go to a URL on your machine. We're going to go to localhost, and we're going to go to 1888, just with HTTP. And this is the URL for the Jupyter server. So you should get an interface that looks very much like this. So I'll just pause briefly. Is everyone, you can say if you don't get this in the next 30 seconds or so, and we'll pause and try and fix it.
Localhost 8888, right?
Localhost 18888.
Sorry, got that right.
When we run locally, we tend to use 8888. When we run in Compose, I basically just added 1 to the front of all the numbers. That's basically where it came from. And in the Kubernetes environment, they tend to begin up in the 30 range, but we'll get onto that later. So it's localhost 18888. Be able to see that in the browser there. I'm going to start off by just opening the README first. I'll make this window a little bit bigger. Hopefully everyone can see that okay. So this is just an introduction, and we wanted these labs to be self-help, basically, that anyone could go along to them and learn a little bit about how to use them. So we've probably talked about quite a lot of these things already. I guess a key point to note is that all of these exercises are built on this fictitious company we have called Cohort Pharmaceuticals, which is doing clinical trials. Seems quite topical at the moment, with a whole series of personas. And so we've tried to build all of the samples around these particular personas and what this business is actually trying to do to support governance of their data. So this gives us quite a bit of an introduction to that. There's more about Cohort Pharmaceuticals at this link. And Jupyter Notebooks, if you just search Jupyter in Google, we should probably put a link in there. That will tell you more about the Jupyter technology. I'll bring up one of these notebooks in a minute, but up at the top, you'll see this toolbar. And that red circle there is the play sign, basically. And this blue arrow we've got down the left-hand side shows the current cursor. So if you imagine the notebook has a series of cells, a bit like a spreadsheet. And as you press that play button, you go from one cell to the next cell. And that's how we progress through either reading the content or actually executing the code, which we'll see in a minute, in each of those cells. It also provides ability for editing, but we won't be doing that here. So the first notebook that I'm going to start up is actually going to be I'm going to go through the server config notebook. So we're going to skip over to this notebook now. So if you just double click on it, it should open. Okay, and this is now going to describe the scenario that we're going for. So this company, Cohort Pharmaceutical, they're trying to do a lot of things to improve basically how they manage their distributed systems and metadata they have about them and actually govern that. And of course, they're going to use Egeria to do that. And the character that is going to be responsible for setting up the sort of IT environment at Cohort Pharmaceuticals is this persona called Gary Geek. So you'll see Gary Geek as the user ID in quite a lot of these requests, and this is a picture of Gary Geek. So that section there, I should do what I've just been talking about, actually move the blue arrow forward. When you click it on a text segment, it will actually effectively not do anything. It's just going to navigate to the next step. But when you click it on one of these sections, which is a code fragment, it will actually execute it. And you see the square bracket on the left-hand side. Once you actually execute that, you'll see that will change from blank to a number. And when it's actually executing, you'll see a star. So if you see a star for a long period of time, it means it's taken a long time. Possible something's gone wrong. Some things do take a long time. And if you see a number, it means that you've done it already. Generally, most of the notebooks you can run through repeatedly without a problem. Sometimes it may be an issue. Just wanted to check, is everyone able to get into the notebook and just navigate through that first statement? Okay. I'm presuming so.
Yeah. So
okay.
If you've got problems, put something in the chat as I'm monitoring. Nigel can't actually see the chat, so.
No, I can't. It's useful, that, isn't it?
No. So you go on blindly, going through. But I think it's
okay. Cool. Okay, so this is setting up some variables in Python, which we're going to use later on in the scripts. Now, an important thing here is to describe the different systems that Coca Pharmaceuticals is going to use. And in particular, what we care about is the servers that they're going to use for Egeria. So we've come up with these multiple servers that they have. The key ones really to think about for now are going to be the first four. That's what these notebooks initially focus on, which is around the daily operations of data in a data lake, what the governance teams use, some research work, and some general users. There's some developers as well. And so you'll see a picture of that, yes, a little bit further down. So we're going to go on to that picture, I think, because that'll be quite useful. The Python code that we're running here is in this common directory that you'll see over in the nav bar. We don't actually talk about that in detail as part of the tutorial, but what we've got in there is a whole set of standardized functions. And I think as the notebooks have been written, it's almost becoming like a Python API for Egeria, although it's not packaged like that at the moment. And it's trying to get that right balance between educating people in how Egeria works, as well as trying to make it easy and explain the concepts. So feedback on how we've approached this is very useful. So this picture here, the next one, is about how those different servers run on different platforms. We talked about wanting to have 2 platforms, the exercise. In fact, in this environment, we're going to have more than that. But let's focus on this first 3. And you see we've got different servers here, and Data Lake users 4. This is where normal users who are accessing data in Data Lake, and we'll see a lot of them in the notebooks, interact, and that's on this OMAG server platform here. And then we've got interesting ones here like the governance team over in this core platform. But what we're going to focus on here is really these logical servers, which are in the white box. They are the things that form part of a cohort, whereas the platform is really just that container in which they run. It's just a Java process in which they run, which is, so we've effectively got multi-tenancy there at the server level. Okay. So we're going to have 3 cohorts. I'll just scroll back so you can see the picture better. And if you look at this diagram, we see that different servers are in different subsets of cohorts. So Coca cohort is the main one that pretty much all of our servers, until we start talking about an IoT environment, feature. Whereas there's a separate development cohort, which will share information between Coca MDS2, which is our governance server. That's where the governance team work, and the development team. But that won't be exposed to the other servers that are in Cohort, like the Data Lake users. They're dealing with operational data, so we don't want to exchange metadata with them. We just want to keep this scope to development. So that's what the dev cohort can be. And if you look at a system like Coca MDS2, it's actually in 3 different cohorts. So it's got visibility to all of that metadata split across all those different servers. So these are 3 that we're going to use: Coca cohort, dev cohort, and IoT cohort. So we talked earlier about Kafka. That's what we use as the implementation for the message bus. We didn't actually quite get on to configuring that in the Postman collection, but you'll see some example requests in the Postman collection where we specify URL for Kafka. In a local environment, if you're playing the development environment, it's usually going to be localhost 9092. In the Docker Compose environment, it's actually, if I flip to this window over here, running on one of these containers, which is called something like Tutorials Kafka 1. And the way that we inject that into the notebook is this first line here, which is interesting, which is we're actually getting a value from the environment. So this has been set under the covers so that the user of the notebook, who may not be a developer and may not be getting into Egeria at the level we're getting in today, just gets those variables correctly set. So that would be set to this Kafka server over here, port 9092. So we're going to run that. And this is composing the event bus body is part of one of the REST requests, the request bodies that we need to send to Egeria to configure the server. Carry on going forward. So OMASs are our open metadata access services, and so they're really a consumer-centric view of the metadata in Egeria. So a particular tool, we hope, will just use one or maybe a couple of different OMASs. So the data will be in a form that is suitable for that kind of use. So we have like asset catalog, and that's going to be used when you're doing kind of general searches for different metadata that you want to use. Whereas if you're trying to set up a governance program and define your governance strategy within the organization, that might be the governance program OMAS that we would use for that. So what this table represents is how those different capabilities are split across the different servers. And this is all done through configuration, and we'll see that further down. We can enable or disable these different access services at a per server level. Okay, so we've gone through a lot of this. So what we're doing here is building up a URL to actually execute some configuration commands. I'm just going to go forward a little bit. We've talked about the security plugin earlier. We've talked a lot about the security plugin and page size. Okay. So this cell is the one that's actually doing quite a lot of work. So all of that stuff that you did with Postman earlier, we basically do it here. And these are all calls into that common Python library effectively that we talked about earlier. So we're just going to execute that. And you can see we've printed out the posts that we're doing. So dev, that's going to be the development platform on which we have a couple of servers, including Cocoa MDS1. And we're actually running all of these requests for configuration against a single server. So we're building up those configuration documents, and later on you'll see what we do with them. But for now, we're just creating definitions basically for each of the servers. We're not starting the servers, we're just defining what they should look like. So Cocoa MDS2, you can read this in more detail as well in your own time. This is got a different set of capabilities. This is for governance, so we're going to run that one. Tell me if I'm going too fast or too slow, Mandy. Let's go through all kinds of different speeds. Okay, cool. Cocoa MDS4 is one of my favorites because that's where all the data lake users hang out. That's where we'll be pointing the UI at. That's where a lot of activity will be. So again, it's running different ones. Note, again, it's running exactly the same platform. It's running against dev. Cocoa MDS5. Business systems and ETL. 6, we haven't really got on 6 much for manufacturing. We've set all of this up in advance so we can build more stories around it. And here we're actually doing some stuff for the development team. So this is Cocoa MDSX, and this is the server that's going to be in the dev cohort, which will we can see what OMAS is here, for example, we've got for developers. So again, this has done all that hard work that you did with Postman, but much easier. I guess we haven't spoken so much about this. You may know, but we have a discovery framework in Egeria. So this allows us to go and look at systems and figure out what is interesting, get the metadata, create linkages between things, and we have some samples that we ship as part of Egeria, but the idea here is that organizations or companies can develop their own and plug in to Egeria. And this is just taking us through an example of how we actually configure a discovery server. There is a particular notebook that goes into more detail and describes this discovery process in one of the folders here, I think it's under administration. So we'll go on to that. So this is the point I was getting at. We've done all of this configuration against a single platform. We've created all of these documents, which is what the diagram on the left-hand side represents. What we're now actually going to do is basically push this out to all of the other platforms. And the first thing we need to do is check they're running. So remember, we had Data Lake platform, Core platform, Dev platform. We actually had Factory in the image as well, which we're not using yet. But those will be 3 separate Docker containers effectively running the Compose environment. So this is just checking they're active. And now we're actually going to issue a call that will take those configuration documents and push them to the correct platform. So for Coco MDS1, that's Data Lake, and you can see the rest there. Okay, so at the end of that, what we've done is we've set up configuration for all of the servers that we want to use. So we've got 6, 7, 8 different servers. We've got 3, 4 platforms, and they're all set up. They're all pointed at the same Kafka. So later on, they'll be able to communicate with each other and participate in these groups that we call cohorts. Any questions at this point?
Yes. What's the reason you used a notebook to do all this? Just for the demonstration purpose, or other consideration?
So I guess the reason we started looking at notebooks is that we ran some labs very early on. It was maybe a year or 2 ago. And it did take quite a long time to get through the process of issuing the post requests to configure the server to an audience where really we wanted to get over that initial message of what Egeria was all about. So we wanted to explain the concepts and actually show it working, because I think people always like to see code really working rather than faked or recorded. And the notebooks were an interesting way of combining explanatory text, so descriptions, diagrams, with fragments of code. And so we thought we can walk them through this process and try and combine the technical setup with the explanation of what they were doing at each stage. Of course, once someone wants to then set up their own environment, we do need to get into more detail. They need to work through the admin guide in more detail, and that's some of what we've been trying to do today, and walking through the details of the postman requests. Because one challenge of the notebook environment is people can very quickly go click, 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 and not really pay attention to what they're doing. So that's where we came at notebooks from. Anything to add on that, Mandy?
No, you've got it perfect. I mean, if you think about how much work it was, and to get one server done when we're doing it with Postman, trying to understand what requests, get the right values in. Whereas here, you can go through this slowly and look at the requests, or you can just hit play all, because there's a run all, I think, button, and it will just create all the configuration, and then you can focus on other. Yeah, that's it. Then you can focus on other aspects of the process, and so it means it's easier for people to pick and choose with it. The downside is that we've had to build this Python library, and as Nigel said, probably we will turn it into a proper client library for Egeria, because tools like this are so prevalent, and Python's used in so many different sort of scripting environments and things. So we have Java clients as well. So,
all right, thank you.
No worries. Any other questions? Okay, so the next notebook I'm going to open up is the server start notebook. So far what we've done is we've created all those configuration documents and we've pushed them to the right platform. And what we're going to do, and I'll go through this one a little bit more quickly, but you obviously can go back to it at any point in time. So we're going to do a little bit more quick clicking here. Again, we've got this guy called Gary Geek. And we've actually, in fact, originally we had this all verbatim in the notebooks. We had all the different commands to start it. Because all of our notebooks need to be able to do this, they all require these servers to be running. We've actually put it into the common library. And in fact, I can open that now and show you what's in there. So if we look at environment check, this is actually all of the details of basically issuing the JSON requests against the server and starting the servers up. So what I'll do this time is I'll show you what we just talked about, which is we can do a run all. And what you'll see as you go through is the numbers represent the cells that are responded, and a lot of these where they just set variables, you don't see any output. But as we go down, we'll start to see some output. There's a lot of definitions of this. Is why we just said it's becoming a Python library, really. Just scrolling down. And basically it's starting up the servers, so it becomes a single click at this point to start up the servers. And I have to admit, even as a developer on Egeria, I actually use these notebooks a lot because I can just quickly start up a standard configuration that is useful for testing, because we've got a number of different servers, so they're communicating with each other, so it's a good environment in which to try things out. It does take a little while for each to start. And what we can actually do as well with Docker is we can actually do, see, I mostly use Kubernetes, so Docker seems old-fashioned. Okay, we can look at one of these servers, and if we look at Data Lake one, that actually will show us the output that you would normally see on the command window if you were running the platform directly. And you can actually see all of the audit log messages. By default, audit log messages go to standard out, but we've got an audit log framework that allows you to put in a plugin for that to go to different destinations. But it's a good place to look at if something maybe is going wrong, something unexpected, or if you want to understand more about the behavior. So we tend to record information here like re-registration requests. When each of these servers are starting up, they're basically publishing a message on a topic that has a name that relates to the cohort, so it has Cohort in the name, to say, I'm here. And all of the other servers hear that, and they go through a communication process to exchange information, such as what types they have, and they get to know about each other. And we've actually got a notebook that talks through the cohort configuration in a little bit more detail. But looking at the Docker logs is quite a good tip for seeing what's going on. So I've gone completely off the script, Mandy. So
don't worry. But I would go to the platform next.
Yeah, sure.
Because what you're starting, hopefully what you're seeing is you're recognizing, oh, we did this. And so the platform, this understanding the platform is going to issue the same REST calls that you were doing earlier on from Postman. But it's all encoded in the lab, in the notebook itself. So it's a lot easier. So again, it's still Gary, because Gary's the one that does all the setup.
And in fact, the origin is one of the first things we tried. So again, we should see here, server platform 1.8 snapshot.
So what it's retrieving is in the picture of the platform, there are a whole series of subsystems, OMAG subsystems, and these requests are listing all the registered ones. So there's a set of common services that are core to the running of each server. And so, like, for example, the security services, which is the thing you were battling with before, and the repository services do all the cohort management. So those are the sort of common services. Oh, you've got admin services there as well. And then if we go on and look at the access services, these are the specialist services that are designed for specific types of tools. So subject area is for managing ontologies and glossaries. Governance program is for setting policies and that type of thing. Asset lineage is maintaining an asset warehouse. So each of these are pointing to different tools and providing simple interfaces for those tools. And then the last set, I think if we go through down a little bit further, the governance services are providing even more advanced function around governing in a particular environment. And then I think the last one is just look at all of them, right? So
yes,
yeah,
all of them together.
yeah, let's just bring them all together. So the other thing that the platform services give you is the ability to see what's running on any of the servers. Now, before it was very boring because we were not looking at a platform that was doing very much. But now in this environment, when we start to query the servers, you can see that on this particular platform, we have 4 servers running. And there is a distinction between servers that are known. So those are ones that have run on the platform but are not run at, at any time. And then the active ones are the ones that are actually running. So if we shut down Cocoa MDS2, it would remain in the known servers list, but would disappear from the active servers list until we restarted it. So that's how we can see what's running on the platform. And then there's various statuses, so you can find out if a particular server is active, and then also to see what services are active within the server. So you can from that querying, you can see what type of server you've got in that particular piece. Because from the outside, every server looks the same to the platform, and it's only the configuration document that controls the services that are enabled.
Well, one interesting tip as well is as you're trying to learn about the server, one thing I do sometimes is I just go in and add an extra line to the notebook and issue the extra call that I wanted to understand how it works or why it's broken. So you can use that sort of effectively that Python library. It uses Python request library to issue these requests and then just use that to help learn basically. So we have a number of different notebooks.
Yeah, I did the cohort one next because that ties in.
Do cohorts.
Yeah. So is everybody following along?
Okay. So is everyone able to run this in their own environment? Okay.
Everyone's very quiet.
Hopefully, so good. So this is the diagram that we looked at earlier, which is showing which of the metadata servers belong to which cohort. So this dev cohort, which, as I said, was just governance and development, whereas we've got Cocoa cohort, which loads of our servers are actually collaborating with. So that visibility of the metadata is controlled by which cohort these different servers are in, which is a very useful technique. But it's all peer-to-peer, and we have this thing called the cohort registry store. And that actually gets set up as as these servers communicate with each other and see these pub/sub messages appear on the message bus. They learn about their peers within this network. So we've done that initial setup when we started the servers because they all started broadcasting the fact they were here and part of the cohort. So we can now go and query them. And this is actually, I don't know which server this is talking to, but this is...
So it's a repository services. Yeah, repository services.
And this gives us a perspective from the individual servers. This next one's going off to Cocoa MDS2 and asking it what it thinks its registration is. So we've got the root URL there. So this is on this platform that we had called Core. Notice that in the Compose environment, all of these different containers are just running on their default port of 8080. So within the Docker Compose environment, they're distinguished by name. They're effectively appearing as if they're completely different machines. It's only when we access them from outside that Compose environment, we've renumbered them. So you might have them running at 18080, 18081, 18082, etc. We can have a look at that. It's documented in the README as well as in the Docker Compose YAML. So we can see what time they registered. This is good for debugging. So if there's any problems with servers communicating with each other, it's very useful to go and issue these requests to see what cohorts a server thinks it's a member of, and then later what other servers think, what other servers, what's the right word? Asking one server what other servers it knows about, which is the remote members in this last request. And this is relevant because this is effectively the visibility they have as metadata changes, and they're publishing those messages, say, to Cohort. It's going to be the servers that are in that cohort that get to see those changes, and therefore will know about them when you use any of those open metadata access services, because they'll be able to effectively find them and make sure things are updated in the correct places. Okay. Do we have any questions about cohorts?
Someone said, there's a question here. Can you please explain the cohort again?
Can I explain the cohort again? Okay, let me go back to this picture. The principle of a cohort is basically a group of servers that will exchange metadata with each other. That's really what it is. But a server can be a member of multiple cohorts. And so in this diagram, this server Coco MDS2 we'll see is actually a member of Coco cohort over on the left, Dev cohort on the right, and IoT cohort below. So it actually will have visibility to changes occurring in any of those other servers in each of those cohorts. So it's pretty much going to know everything in this environment. Whereas if you look at another server like Coco MDSX, which is on the right-hand side, development, that's only going to see things that are happening within the dev cohort environment. So you're more likely to be experimenting, creating data sets and then adding the metadata for them, adding them as assets. In that environment, you don't want to interfere with your operational environment. So there's no reason why that information needs to be shared at all. So a cohort, it's a server can be in multiple cohorts. It may not be in any cohort. And the cohort really controls the sharing of metadata between servers. And it's all peer-to-peer. Anything to add, Mandy?
No, not really. It basically, Egeria is creating this metadata sharing environment, but we need to control who it's sharing with. And the cohort is just the set of servers that are sharing metadata together. You got a thank you, so I think it's good.
Cool.
So where should we go next?
We could go to assets, or you could do discovery if you prefer.
Yeah, let's do the assets.
I think assets makes sense. Building a data catalog.
Yeah.
It's one of my favorite notebooks. So we have some different characters appearing here, or different personas. So we have good old Peter profile, and we have Erin, and we're going to talk about them a bit later. So I mentioned that Coco Pharmaceuticals is this hypothetical organization we're using. I think we've seen that diagram, and I must do the play just so that it makes sure it executes the code. If you jump to the wrong randomly into the middle of a notebook, you'll probably find you'll get an error from that particular Python cell because things won't have been set up. So that run is just making sure the servers are running, but as you can see, it already has been. So let's go that. Okay, so this is really where the real story starts. So this guy called Peter Profile is going to add some new data sets, and basically we call these that they're cataloging assets in Egeria. So it can be lots of different kinds of assets, whether it's CSV files or Avro files or relational database tables, etc. But here he's going to create some files. And every asset, we have lots of metadata about it, such as where it is, information like who owns it, etc., which is obviously quite useful when we're trying to do processing of it. So Peter is the owner here. So he's going to use what we call the asset owner OMAS service. So I'm going to look first to see if he's got anything. He doesn't have any assets at all. So he's had some trial data from the clinical trials. He's got 3 weeks worth, I think. So I'm going to start with week 1. And what we're adding here in this particular cell is a CSV asset. This is actually one of the, this is defined within that common library we talked about earlier, but you can actually dig in and see what the REST API call that it's issuing is. So we have particular support for CSV. And these are the GUIDs that have come back as part of the creating of that asset, which is explained here. Because if you look somewhere, we've got this file, secured research, clinical trials, dropfoot measurement, week1.csv. And so what we've actually done in that call is, rather than there just being this single asset with this path, we've actually got a hierarchical structure here, which is the file system. So we've automatically created that within Egeria. And that's why we have all of those assets. Go down. So we're going to use this later on in the script. So that's the actual file. And if we do a search now, we'll see, I might make the window slightly wider, maybe a little bit clearer. Probably a little bit better. And we've actually printed out, this is all formatted in the Python script. And here's the actual file at the bottom. So we've got all the folders, and there's the file. And useful, there's a lot of information in Egeria on the website about the metadata model. And some of these, I suspect these are links to that metadata model, if I just click on them. Exactly. So when we talk about some of these concepts within the notebook, you can just click these links and get a better explanation of them, like the reference to what the software server capability is and why it's not an asset. And that's actually quite useful. And in fact, hopefully when we look at the UI later, we'll probably look at the Type Explorer and maybe Instance Explorer, which can help you understand what we actually have based on this model. So let's go back to the notebook. So that was the first asset. Well, actually, it was 5 assets. It was the first file that he created for week 1. He's now going to create the other week's assets. It's following exactly the same Python scripts, but we'll get 5 of them for each one. And these are the actual files that got created. So that's Peter's work done, really. He's the owner. He's created his assets. They're all there now. So what does that mean? There they all are. Perfect. But actually, what's important is that this information is shared. And so we have Erin, who's actually going to make use of that information. So she's not the owner of the assets, but she's actually the user of them. She's going to be using Cocoa MDS2 in this case. If we go back here, we'll note, just scroll back a little bit, that we were actually using Cocoa MDS1 up here. So these are 2 different servers, but they are actually members of the same cohort. So we're going to show how information gets shared between those 2 different servers. Let me just go back to where I was. I think it's here. Oh, I think I might have done it again. Oh well, never mind. It's always good to have lots of assets. They'll all have unique IDs. So there you go. We've got 2 and 1. If we look at this diagram, 2 is over here and 1 is over here. They're both in Cocoa cohort. So as per the explanation, they should be sharing metadata. And in fact, when Erin now goes to query against Cocoa MDS2, she can see those exact same assets. So we've got 2 different servers, running on different. Are they running on different platforms? I have to check the topology. I think they might be running on different platforms. Yeah, and they're communicating. So what we also have in Egeria is the ability to add comments to assets. So this is going to show you an example of how to do that. And this is actually going to be a discussion effectively between Erin and Peter. So in reality, this is more likely to be through a GUI or another kind of tool, but what we're showing here is how to do that using the actual REST API call. So this is how you would integrate it into some kind of application, make use of that capability. So Peter added a comment because, was it Peter? Sorry. Erin added a comment, and Peter is now actually able to look at it. And he's wondering why, she's wondering why there's much less data, and is able to reply. So this has got a link basically between the actual asset and then this set of comments that apply to the asset. And we've got various ways to go and look at that. And what I suggest, if you're interested in these, in how exactly this is done, is you need to go and look in the common folder and look at how we've written those Python scripts. And I think we did talk, Mandy, about whether with some of these things, when we're talking to people about the REST APIs, it might be nice to actually show the REST calls in particular as well, to see how they're done, because it's kind of hidden behind the Python library at the moment. Asset universe is a fairly broad query that basically takes an asset and goes out and finds a lot of information about it and its linkages. So we should have a fair bit here. You've got common count, okay. So we would then have to go out and use the GUID and go and actually retrieve the comments.
Yeah, it gives you a count of what's connected, so you can then choose what you then query for. Just
it's always a challenge to decide how broad to go at these different levels. How much you get in the response and how much you then go and query afterwards. So that was me issuing it again. Okay, any questions so far?
Yeah, I mean, that picture is probably worth pausing on, because what it's showing is that not only are the two characters connected to different servers entering and linking data as if, you know, they're seeing each other's data as if they're in the same server, but actually we're managing to link between metadata that's stored in different repositories. So the comment that Erin made was created in Cocoa MDS2, and it's linked to the asset created in Cocoa MDS1, and the reply is also from Cocoa MDS1. So it doesn't matter which server you use to create the metadata, we can maintain the linkage as if all the members of the cohort are in a single logical metadata repository. So that's how the cohort's working. It's completely invisible to the callers through the access services. So the repository services sits underneath, and it's responsible for all that stitching together of metadata as the requests are happening.
Okay, so we're now going to just go on to talk a little bit about security and how to protect access to these the metadata for these different assets. So we've got a new character, called Callie. She's a data scientist, and she wants to work on these files as well. And she's actually using Cocoa MDS3 in this example. So let's see, let's let her get them. Ah, she can't see them. Ah, that's a shame. There aren't any there. Or are there? So even though we've got the assets, she can't see them. And that's in this case because the zone that they're in. So when the assets are first created, they get put into this quarantine zone so that they can be appropriately, I guess, edited, appropriate attributes set. So to define what that sharing should be, in other words, which zone they might be in. There's trying to think where the zones are documented in more detail.
I'll get the link.
Yeah, that link might be useful to people to understand the different zones. This kind of goes back to a lot of discussion, a lot of work that happened on the data lake in recent years, and how large enterprises can organize their data, basically based on the kind of quality and the way in which the data is used, and that's what these zones are. So as we can see here, we've got this quarantine zone. That's where they've been put in, but it's the data lake zone where users, so data scientists, etc., are actually going to find their assets. So their queries are going to go only to the data lake zone. So that's why at the moment, Cali can't see anything. And this supported zone is an example of what those different OMASs on the different servers are set up to support in terms of what zones they work with by default and which zones they can actually access. And this is all part of that API that we have. So Cocoa MDS1's asset onboarding, which Peter used, is set up to, by default, just put it into the quarantine. But he does have access, or this server does have access to the data lake zone, which we'll see use of in a minute. And good old Erin can see everything. So governance rules, I guess. So let me carry on playing there, so we can have a look at those pictures in more detail. So Tanya, we've got Tanya here.
So Tanya's the owner. So what's happening is that there are a number of things that need to be set up and validated against the asset before it's shared more broadly. So Peter's receiving the files from hospitals and will run discovery and quality checks and various other things, as well as set up the security for the asset. So by putting the asset by defaulting the zone of the asset to quarantine and not allowing any servers to see assets in the quarantine area, it basically means it's hidden until it's properly set up. And
I just rejoined. Is this a break? Oh, lost audio. So
did you just mute me?
I don't know if I just muted you. I just joined. Maybe we're back.
I don't know. I was talking for a while, so
Hi, sorry. Can you hear me?
Yes.
Sorry, I've had some more device problems.
Okay, so obviously when I rejoined, something happened, or unless Nigel coincidentally did something.
No, I think my headsets are old and the batteries are running out, actually.
Okay.
Okay. They can deal with a 1 or 2 hour call. They struggle with it all day. So I'm just looking at my microphone set properly.
So I don't think you were hearing me when I was talking about the zones.
No, sorry.
Okay, I don't know how I ended up on mute.
Okay, I'm back.
Right.
So we're talking about Tanya. I think, yes, you were explaining about the zones, Mandy. I didn't hear the full explanation, but hopefully you've done that explanation.
I'm not sure, but
no, Nigel, neither we didn't hear it either. I think there was 2 problems going on at the same time. You lost your audio, but Mandy got muted as well.
Okay.
Okay, so let me quickly go back to the zone. I've put a link if you want to see all the background, but the zone is a very lightweight mechanism. We maintain in each asset a list of the zones that asset is in quotes. It's membership. And each of the services, when you set them up, you can say which zones it's supporting. So you could think of it as as a sort of portal or view of which assets are visible through a particular interface. So the data lake users are quite general users, so we need the assets to be properly set up with all the access control and all the proper values, like who is the owner, before they see it. And in a normal environment, you have different metadata repositories and people connect to different repositories. But now we're sort of sharing everything everywhere. We have to add that virtual scoping support effectively on what everyone can see. And that's where the zones come in. And as I say, it's very, very lightweight. We just update it to move an asset or to add an asset to a new zone. We just update its properties. And then, you know, that asset is published around and suddenly it's visible to different places. And that's what you're seeing in this particular notebook, how the fact that Erin and Peter can see the asset while it's in the quarantine zone, but it's not until Peter, or I think it's actually Erin, changes the zone to something that Callie's metadata repository can see, will it actually work. And so Tanya is the records, she's the clinical records clerk. And so ultimately she's going to be the owner. She's going to be responsible for the correct use of this data in the company. Peter's just the administrator bringing stuff in. So the moment that Tanya is the owner, everything's ready, the governance zones are updated, and Callie can see them. So it's just literally that last step, update the zones, and then it becomes visible to Callie. Does that make sense to everyone?
Yes, thank you.
Okay, good. So it's probably worth doing this bonus material and then we'll give everybody another break.
Okay.
Yeah.
So this is talking about the actual repository services.
Yeah, so the aim of this bit is to look at a little bit more, to look at, so under the covers, all of that sort of linking and creating that virtual graph of metadata across the servers, managing the current servers is all done by the repository services. And the repository services does it because it doesn't really know about types of metadata. It manages everything in a sort of type independent way. And so when you look at the repository services interfaces, you see very fine-grained objects called entities linked together by relationships. And then there's an extra thing called a classification that we can attach to things. And that's how the zones are done, actually, through the classification. And so this piece actually retrieves information from them, sort of going underneath the covers and pulling on the low-level interface of repository services to look at these assets. And you can compare sort of what you see with repository services compared to what you see with the access services, which are the more application-oriented interfaces. So there we are. Nigel, over to you.
Thank you. So what we're going to have a look at is the metadata collection ID. It's the unique identifier for the metadata that this particular server, Cocoa MDS1, actually owns. So building up the request here. In this case, we do actually post it. So you've probably got access to this in Postman as well. So this number will be unique. And if this number changes, well, it's basically a different server, because each asset will actually have the ID of the metadata server that created it stored with it, so that we know where to send updates. So if we look at Cocoa MDS2, I'll just scroll back a little bit. We should see that, if I can get these both in the screen, we've got two very different IDs here. Sorry, I was reading them as the same for a minute. I thought that's wrong. They are unique. Okay. And this is the point here. This must never change, because you won't be able to update the metadata if that changes. It's effectively a different server. One thing we should talk about with repositories is we do, as part of Egeria, have an in-memory repository and we have a graph repository. Most of these notebooks are set up to use the in-memory repository. We have some compliance tests in another notebook that does actually use the graph repository as well. Graph repository is based on Janus Graph, but also you can implement your own connector to a metadata repository. So you can have a very heterogeneous environment with different metadata server repositories on different servers, or different metadata repository technologies on different servers. But also a server doesn't have to have a repository at all. And in the diagram at the top of this notebook, actually Cocoa MDS4 does not have a repository. So when you issue a query against it, because it's a member of a cohort, it can actually issue queries across the other servers and get the metadata that way. So you don't have to have a repository. And this is intentional. As you can see here. First time you see it, you might think it's an error, but this is just giving you an example of these different errors that come back so we can understand what needs to be done. And in this case, it's telling us that actually we don't have open metadata services available. We're trying to do a query of the metadata collection ID, but if it doesn't have a metadata repository, there is no metadata collection ID. Those services are not active, so it can't supply one. And so what we're doing here is we're going to get, actually, this is a full set of information about this particular asset. So this is one of the ones we created up above. And we can see the full, what we call the entity detail, which is a lot of information about the entity. There are finer grained things we can get as well, but this is pretty much everything. So this goes on quite a lot. But you can see all of the different, this is to do with the separators in the file, for example, delimiter character. And it's worth looking at the models that I clicked on a link to earlier to understand what we actually have for these different types. Egeria has a couple of hundred types out of the box. And they all have different attributes. Also, the UI, I think David will show, should let us visualize that more easily and see what the different types are and what entities are associated with what types. So this is actually a comment, I think, that we're looking at here. And this has got very different properties. It doesn't have a separator, for example, because this is a comment, not a CSV file. And then relationships. So, and Mandy, I think we were touching on this earlier, which is that we can have relationships between entities that are in different metadata collections. So we may be using 3 different collections, one for the relationship and one each for the 2 ends of the related entities. Which makes it quite powerful, especially if you may have metadata repositories that are not the graph or in-memory that we ship, but are provided by other people, may not have every capability to do references between those 2 types, may not support the right types. That's fine. You can use a third repository where you actually store those relationships. And this is the kind of information you get back when you're searching for those relationships. It's worth looking through this in quite a lot of detail because there's a lot of information here. And this is probably very educational when you start looking at those API requests and that model in detail as you're trying to build up your applications or usage of Egeria. I would recommend the Type Explorer and Instance Explorer, which we really should look at to explain this in a bit more detail. So I'll skip through this particular bit. It goes on quite a bit. I think we talked about cohorts.
Yeah.
So we won't worry too much about that. We talked about the security plugin earlier. It's an example of an error, and I think we've done the platform services, so that's pretty much that notebook.
Yeah, well done. Yeah. So the important thing about the repository services is that we make metadata completely traceable, so we have full provenance of where it came from, and who has control over it, how it's being updated, and this becomes extremely important when metadata is being used to control security and other types of governance aspects. And if all it is a catalog that helps you find data sets, then we don't need this level of control. But because we want Egeria to be used, or open metadata, not really Egeria, but we want things that are engaging in open metadata, which is a very heterogeneous, distributed environment. We need to be very clear about where knowledge came from, so that we can fully audit the system to make sure that that if somebody's got access to something, they really deserve access. You know, it's designed. So that's why there's so much care to have a lot of control information wrapped around each piece of metadata. Okay, so Susan, we have been going quite a while, and I think everyone deserves a break.